Hi everyone, we're going to look at the second part of our 3.11 notes, which is now that we have secant, cosecant, and cotangent and know what those are by definitions, we can actually solve equations involving these as well. So just as we were able to solve equations involving sine, cosine, and tangent functions, we can similarly solve equations involving the reciprocals. To do this, it is generally best to isolate the trig function first in the equation. So we want to get cosecant by itself or secant of x by itself. And then we want to use reciprocal properties to rewrite equations in terms of either sine, cosine, or tangent. When we use these reciprocal properties to rewrite them, what we're actually doing is we are going to flip both sides of our equations. Whatever we do to one side, we have to do to the other side, and then we can go ahead and finish solving like normal. So looking at example 5, it says let f of x equals 4 times cosecant of x plus 3 and g of x equals 11. In the xy plane, what are the x coordinates of the points of intersection of the graphs of f and g for the interval from 0 and 2 pi. So let's break this down a little bit. This right here stands out to me because that means I'm just looking at one revolution around my unit circle. So I don't need to include that plus 2 pi k or plus pi k because I don't need all my solutions. I need just the ones that are on the unit circle. If I'm looking for the intersection of two graphs, that means I'm setting them equal to each other. So I'm going to start by writing 4 cosecant of x plus 3. That is f of x. And I'm going to set it equal to g of x, which is just 11. So now I want to use my algebraic properties to get cosecant of x by itself. So I'm going to subtract 3 from both sides. And then I'm going to divide both sides by 4. So I have cosecant of x equals 2. Now that I have cosecant of x by itself, I know that by definition, cosecant of x is the same thing as 1 over sine of x. So I just rewrote cosecant by definition of what it is. Now that I can see sine of x, that is what I want, one of my 3 that I want, it is in my denominator. So technically what I could do is multiply both sides by sine of x to get it out of here and then divide by 2. Or I know that 2 is technically 2 over 1 and I can do the reciprocal of both sides and flip it. So I'm going to flip both sides here, which means I'm going to have sine of x over 1 is equal to 1/2. Now I can finish solving this. I want to take arc sine of both sides. Arc sine of sine will cancel this out, so I'm left with x by itself. And then arc sine of 1/2, I want to look at my unit circle. So arc sine of 1/2 gives me 2 angles. I get pi over 6 or 5 pi over 6. So those are my 2 solutions for example 5. Let's take a look at example 6. So part A, we are using the information up here. So we have h of x, j of x, and k of x. And it's asking us to determine the x coordinates of the points of intersection of the graphs of h and k for 0 to 2 pi. So again, this is just one time around our unit circle, and I'm looking at h and k. So I'm going to set this up, and I'm going to set them equal to each other. H and then k is 4. So I want to do the same thing like we did in example 5, and I want to get my trig by itself first, which is secant of x. So I subtract 3 on both sides. And then I'm going to divide both sides by a -1/2. So I get secant of x by itself. When I divide this by -1/2, that is the same as multiplying by the reciprocal. 1 times negative 2 is negative 2. By definition, secant can be written as 1 over cosine of x equals negative 2. Now I'm going to do the reciprocal and flip both sides. So I get cosine of x equals negative 1/2. To solve for x, I'm going to take arc cosine of both sides. Arc cosine of cosine is just x, and then arc cosine of negative 1/2. So what angles have a cosine value or an x value of negative 1/2? Well, that's 2 pi over 3, and then 4 pi over 3. Again, I don't want to add my 2 pi k because I'm just looking for what's on my unit circle, not all my solutions. For example B, we are solving for the points of intersection for j and k, just the x coordinates of those points. So I'm going to set it up the same way. If you want to pause the video and work ahead, and then you can restart it to see what I get, that would be great. All right, so I got to the part where secant of x is by itself. Since I was dividing both sides by negative square root of 2, I did just pull the negative out in front. And then I'm going to rewrite this in terms of cosine. So secant is 1 over cosine. And I have negative 2 over the square root of 2. I flip both sides of my equation, so I get cosine of x equals negative square root of 2 over 2. So that's one of the reasons why I pull the negative out in front. I can just flip the fraction. As long as that negative is still there out in front, it's perfect. So I'm going to take arc cosine of both sides. Arc cosine of cosine is just x. And then arc cosine of negative square root of 2 over 2 is 3 pi over 4 and 5 pi over 4. All right, our last example in this notes is example 7. There is a calculator symbol here, which means we are going to use our calculator for this one. So we have p of x, and it asks us to find the x coordinates of the points where p of x equals 2 for the interval between 0 and 2 pi. So I'm going to set this up. 3 minus 1.7 cotangent of 0.5x minus 1 has to equal 2. So I can go ahead and solve this by hand until I get to a point where I do need my graphing calculator. I'm going to subtract 3 on both sides. And then I'm going to divide by negative 1.7. Negative 1 divided by negative 1.7 gives me a really big decimal, like a long decimal. I don't want to round this too soon because I still have to take arc cotangent or arc tangent when I flip it, and then solve for x. So I want to see what the fraction equivalent is. So I'm going to do math, enter, to get the fraction. And I'm actually going to write it as 10 over 17. So I have cotangent of 0.5x minus 1 equals 10 over 17. Well, if I have cotangent, that means I can rewrite it in terms of tangent. So that means I have 1 over tangent of 0.5x minus 1 equals that fraction. Now that I have tangent in my denominator, I can go ahead and flip both sides. So I have tangent of 0.5x minus 1 equals 17 over 10, since I flipped the left side and the right side. So I want to take arc tangent of both sides. So on my calculator, I first want to make sure that my calculator is in radians. So I'm going to check my mode, and radians should be highlighted in black, which mine is. So I'm going to do arc tangent, so second tangent of that fraction 17 over 10. And I get this. So I'm just going to write what we did on here. Arctangent of tangent is 0.5x minus 1 because it gets rid of tangent and I have what's left in my parentheses. And then arctangent of the fraction was this decimal. So I'm actually going to keep all of those decimal places because I don't want to round too soon. And then I can add 1 to both sides and divide by 0.5. So I add 1, divide by 0.5. So I get x equals 4.078 since I just want 3 decimal places. Now I want to show another way to do this one since we are able to use our calculator. What we could also do is use our graphing ability. So I'm going to hit my y equals, and I'm going to put p of x in my first spot. So I have 3 minus 1.7 cotangent. Oh, I don't want to go that far. I want to do here. So once I get to just regular tangent and I don't have cotangent, cosecant, or cosecant. So I have something that's not equal to y. So I'm going to type in tangent of 0.5x minus 1. And then the other side of my equation is 17 over 10. So I'm going to type that in 2 separate equations in here. And then I'm going to hit graph to see what it kind of looks like. So what I'm looking at is this curve right here is part of my cotangent graph, or my tangent graph. This vertical line is that asymptote, and then this horizontal line is that 17 over 10. So if I'm looking for when tangent of 0.5x minus 1 equals this, I'm looking for where this tangent curve intersects that horizontal line. So I see 2 of them, but I want to make sure that my window is in the right place. So I'm going to hit my window button. If I just want 0 to 2 pi, I'm actually going to put that right in here for those. So my x min is at 0, my x max is at 2 pi. And let's regraph it. So now I only see that there is one intersection in that interval. So I want to calculate, so I'm going to do second trace. I want to calculate that intersection. And it says first curve. So my spider is on that first curve. I'm going to get it close to the intersection point and hit enter. Second curve, I can tell it's on the horizontal line. Hit enter, and I'm going to guess that the intersection is somewhere right around there. The x value of that intersection is 4.078, which is what we calculated by hand. So that's another alternative to solve this problem.